Most of us expect a specific rhythm when interacting with AI. You type a prompt, the system generates a response, and the transaction is over. Behind the scenes, this creates a stateless environment. When you close your tab, the system completely erases your session's memory. This architectural amnesia creates a hard limit. If you assign a multi-day workflow, background tasks simply fall apart because the AI cannot remember its progress. Reliable digital labor requires persistence. An entity that ceases to exist the moment you look away cannot execute continuous background tasks. Enter Genspark Claw. On the surface, the interface mimics the familiar chat box you're used to, but that text input field is intentionally obscuring a different technical architecture. Look at the top status bar of the UI. You'll see a series of badges. These are not aesthetic choices. They are live system telemetry. Reading these specific indicators changes exactly what you are looking at. This connection indicates that your local web browser is functioning as a remote desktop viewer, peering into an external system that is doing the actual work. Instead of renting a few milliseconds of temporary computational time to generate text, you have been granted an operational piece of real estate in the cloud. Dedicated hardware provides the foundation for maintaining independent state, the machine's ability to retain its memory, files, and active processes regardless of your local activity. You can assign a complex multi-day task, forcefully close your laptop, and completely sever the local connection to the internet. Out in the cloud, that isolated machine keeps running. It continues to process data, manipulate external tools, and communicate across channels without any local user input. This continuous, untethered background processing is the dividing line between a standard conversational AI and a genuinely autonomous digital employee. Because this is a physical machine running an operating environment, it follows the same rules as any other piece of hardware. It requires ongoing administrative upkeep. This explains the maintenance readouts on the top status bar. The Claw version and check update labels exist so you can manage the exact software build currently installed on your isolated disk. Rather than downloading new knowledge into an artificial brain, you are updating the underlying system architecture that allows the worker to function. Right next to those version numbers is the Health Online indicator. Think of this as a literal heartbeat monitor, verifying that the back-end services supporting your worker are active and stable. If that health status ever drops, you can expect cascading failures. External tool integrations malfunction, browser tabs stall, and connected communication channels break down. These diagnostic tools validate that the hosted workspace is real. System vitals and software updaters belong to living, running environments, not simple text algorithms. What looks like a chat window is actually the terminal for an isolated cloud machine. We've moved from interacting with temporary, stateless logic to managing a persistent physical space. While standard AI relies on sending an isolated prompt and waiting for a response, this architecture shifts the user's role toward directing an active environment. Understanding this architecture alters what you can realistically expect the system to do. Because the machine keeps state, you can assign multi-day workflows, knowing the context will not evaporate the moment you step away. Looking at the Claw interface is functionally identical to viewing a remote desktop connection on a human colleague's workstation. Giving an artificial intelligence access to an isolated disk and unique networking and continuous background processing expands its utility beyond simple chat. Permanent, reliable integration into the digital workspace is what makes the labor real.